In this video, we're going to learn how to take the probability of compound events. Compound events means that there are two or more events taking place. To find the probability of compound events, you simply take the probability of each event and multiply them together. It doesn't matter if there's 2 events or 3 events or 4 events happening. You can find the probability of multiple events by taking the probability of each one and multiplying those probabilities together. When we talk about compound events, we need to talk about independent or dependent. In these first couple of examples, independent events are events that do not affect each other. For example, what is the probability of rolling a 1 on a dice and then flipping heads on a coin toss? Rolling a dice and flipping a coin have really nothing to do with each other. When you roll a 1 on a dice or a 2 or 3 or 4 or 5 or 6 on a dice, it does not affect what happens when you flip a coin. Flipping 2 coins is another example. When you flip a coin and get heads, that does not affect or change the probability of when you flip a second coin. If you flip a second coin, it's still 50-50 on whether you're going to get heads or tails. So in order to calculate this, we look at both probabilities separately and we multiply them together. We treat it as 2 single events. So the probability of rolling a 1 times the probability of heads. I'm also introducing in this slide the notation P parentheses and then a word. That means the probability of that event. So the probability of rolling a 1 is 1 out of 6, because there's one on a dice out of 6 outcomes. The probability of getting heads on a coin toss is 1 out of 2. And you multiply those together. 1/6 times 1/2 is 1/12. Another example of an independent compound event. What's the probability of picking the number 7 randomly from a list of 10 numbers and then rolling a 1 or a 2? So we find the probability of picking the number 7 and we multiply that by the probability of rolling a 1 or a 2. So the probability of picking a 7 is 1 out of 10. There's one number 7 out of 10 random numbers. And then the probability of rolling a 1 or a 2, that's 2 outcomes out of a total of 6 outcomes. And you could also write 1/3 there because 2 over 6 is 1/3. And we multiply those together. So 2 over 60. Or if you would have used 1/3, you would have had 1 over 30. We do want to write our answer in simplest form. So those are 2 examples of independent events where the probability of the first thing happening does not change or affect the probability of the second thing happening. A dependent event is an event or events that do affect each other. In other words, the first event changes the probability of the second event. Here's an example. You have a can with 8 green marbles and 4 orange marbles. So there's a total of 12 marbles. What is the probability of drawing a green marble first and then drawing an orange marble without replacing the first one? So again, we have the probability of green times the probability of orange. But in this situation, because we are taking the first marble out and then not putting it back, the first time we draw a marble, there are 12 marbles to choose from. The second time we draw a marble, there are only 11. So the total outcome changes, which changes or affects the probability. So the probability of choosing a green marble is 8 out of 12. The probability of choosing an orange marble is then the number of orange out of the number left, so 4 out of 11. If I had put the marble back, it would have been 8 out of 12 times 4 out of 12. I drew a green, I put it back, then I drew an orange. Those would be considered independent events because I put the marble back, so it did not affect the probability of drawing an orange. But for this example, since I drew out a green marble, and now there's only 11 marbles left, I only have 4 out of 11. So 8 out of 12 times 4 out of 11 is 32 out of 132. Or if you simplified that 8 over 12 to 2/3, you get 8 over 33. Here's some examples that we can look at to determine if they're independent or dependent. So you flip a coin 2 times. Would that be independent or dependent? Well, flipping a coin doesn't affect how you flip the second coin. Right? Maybe whether the coin starts as head or tails changes the outcome, but the result of the first coin toss does not affect the result of the second coin toss. So these are independent. For number 2, it says there are 20 socks in your drawer, 12 of them are white. If you grab a sock without looking, then you grab a second sock without putting the first one back. That's an example of dependent, because you didn't put the first sock back. And why would you? If you're trying to put socks on, you're just going to grab one, put it on, grab another one. For number 3, it says your math, literature, Spanish, history, and science homework assignments are all organized into 5 folders. You randomly choose your folder. You finish your assignment, and then you choose another folder. So this kind of depends. If you choose a folder, you put your homework in there, you put it back into the stack, and then you randomly choose another one, well, then those would be independent events. If you set the folder aside because you've already finished it, so now you have fewer folders left, then that would be dependent. So this could be either, depending on the situation. For number 4, you roll 2 dice. Rolling 1 dice doesn't affect the roll of the other one, so that's independent. And you flip a coin 3 times. So again, flipping a coin doesn't affect the results of other coin flips. So those are independent as well. Okay, so using a deck of cards. Using a deck of cards is pretty common in probability questions. So if you're not familiar with the deck of cards, then you have a little bit extra to learn. There are 13 black clubs in a deck of cards. That's this top row. Make this a little bit easier to see. All right, so there's 13 clubs. There are 13 diamonds, those are red. There are 13 hearts. There are 13 black spades. The 13 cards are the ace through 10. Ace kind of counts as a 1, so 1 through 10. And then you have face cards, jack, queen, and king. Those are all on the right. So there are 3 face cards within each suit. I can't get rid of that blue thing now. All right. So what's the probability of drawing a club? That's a single event. What's the probability of drawing a club? Well, there are 13 clubs, and there are 13 of each. So 13 times 4 is 52 cards. So 13 clubs, 52 cards. That's my probability. 13 out of 52, 1/4. It makes sense that the probability of drawing a club is 1/4 because there are 4 rows of cards. They're all the same size. That's a single event. What's the probability of not drawing a club? Well, there's 13 clubs, then there's 13 plus 13 plus 13 for spades, hearts, and diamonds. So that's 39. 39 non-clubs. The probability of that, when we simplify, 39 out of 52 is 3/4. Notice the 3/4 and the 1/4 add together to give you 1. This is an example of what we call a complement. If the probability of something occurring is x, the probability of it not occurring is 1 minus x. We call that the complement. Sometimes it's useful in probability to find the complement of an event. For example, we said the probability of a club was 1/4. Well, then the probability of not a club is 3/4. 1 minus 1/4. So I didn't have to add up all the diamonds and the hearts and the spades. I could have just said, well, 1 minus 1/4 is 3/4. The probability that it will rain tomorrow is 70%. What's the probability that it will not rain tomorrow? Well, the probability that it will not rain is equal to 1 minus the probability that it will rain. So 1 minus 70%. which is 30%. Okay, a couple more questions with some cards. What is the probability of drawing a heart or a club? So heart or a club, we have 13 hearts and we have 13 clubs. So there are 26 total cards. Use my highlighter. So hearts and clubs. So these are all hearts. These are all clubs. So we count up those cards. That's 26 cards. 26 out of 52 is 1/2. What's the probability of drawing a diamond or a king? So there are 13 diamonds, and there are 4 kings. Let's see if I can draw that straighter. But my answer is not 13 plus 4. The king of diamonds, if you're not careful, would be counted twice, because the king of diamonds is a diamond, so it's one of those 13 cards. And the king of diamonds is also a king, so it's one of those 4 kings. So we just want to make sure that we count every card once. So there are 13 diamonds, and then there are 3 additional kings. So 13 plus 3. 13 diamonds plus 3 additional kings. I know there's 4 kings total, but one of those kings was already a diamond, so you can't count it twice. So 13 plus 3 out of 52 is 16 out of 52, or 4/13. What's the probability of drawing a spade or a face card? So all these at the bottom are spades. And then face cards are all of those. There are 3, 6, 9, 12 face cards. 3 of the face cards we've already counted. Right, these bottom 3 face cards that are spades, we've already counted in the 13 spades. So there are 13 spades plus 9 additional face cards. So make sure you don't count those twice. Like, make sure you don't count these face cards that are spades twice. So 13 spades plus 9 face cards. 13 plus 9. So 13 plus 9 is 22. That simplifies to not 11 out of 13. That simplifies to 11 out of 26. So 22 over 52 is 11 out of 26. And that's it for compound events.